The VM performance dashboard is one of my favorite, so I thought I'd share with you why it is designed this way and what you can do to customize it. First thing you notice that it has a clean layout. It's using colors to convey meaning, right? You can easily see where the things needs your attention, right? And for example, if you compare that with this, because everything is green here, right? Well, this is different. There are problems here. And it's designed top down. It gives you a bird eye view so that you can see lots of VM. Then you can drill down to analyze individual VMs here, right? And then you can select a single VM, then you can look at an actual KPI and showing you both contention and utilization, showing you guest level information, and it gets down to individual virtual disks and virtual CPU and not just taking the VM average. So there's a lot of metrics giving you good visibility. Relevant alerts, so I don't have compliance alerts here, for example. Relevant configuration. You can get down into individual virtual disks and you can navigate to the parent hosts or the parent clusters. So let's take a look at it. By the way, all these things is actually documented here. The design considerations of all these things, right? And then this is the VM performance dashboard. So talking about this chart, it's showing you the worst in the last 24 hours, right? And so what you can do if you are checking your environment twice a day, once in the morning after your first cup of coffee, you may want to change this thing, and then later on you change at the end of the day, you can change it. Instead of one day, let's say you make it every 12 hours, yeah? Now the other thing that is pretty cool is this. This is the worst 20 seconds. So it is not the average of 300 seconds. It is a 20-second average. Now, why do I do that, considering that your SLA should be based on 5 minutes? Well, it's to give you a heads up. Otherwise, you get something like this. You see, this is 3,000 VMs, and they're all green. There's nothing to do. So it's not so useful in giving you early warning, right? And this 20 seconds, just to give you an example, you see this. This is 5 minutes average, this latency. This is 20 seconds. This thing is not 2 times or 3 times worse. It's like 10 times or 12 times. And that is expected, is because 20 seconds is 15 times sharper than 300 seconds, right? And then the other reason is the nature of, say, CPU ready or memory contention or disk IOPS, right? And they tend to burst. So that is why the 20 seconds is a much better numbers for troubleshooting than the 300 seconds. So that's that one. Now, the table itself, this table, right? The first thing you see is the host name. Why? Because that is what the application team or your customers know, right? And then the next thing is KPI bridge. Do read the KPI bridge in details, right? I'm summarizing the 4 resources, CPU, memory, disk network, into a single numbers. So you can see easily which VM is not being served well. Now again, this table is the worst numbers. Again, in the last 24 hours. Again, you can customize that, yeah, according to what you want. And what else? Now, what I want to share here is this table can be driven in 2 ways. Certainly, when you click on a data center like this, it's going to change all this thing, right? But the other thing that you can do also is, let's say, based on this, right? I say you maximize this thing, you see something, or I want to take a look at this, right? And when you close it, there you go. That's that one already. And then when you can, and of course, if you click this thing as you expect, all the analysis is automatically done. Now let's dive one by one. Why is CPU queue the first one? Why is guest rank queue the first one? Well, because the guest is more important than the VM itself. We want to look at the guest first, then look at the VM. Why CPU ready next? Well, because that is the most important counter for VM performance, right? The most important counter for guest is CPU run queue, and then the most important counter for VM is CPU ready. Now, if you are not familiar with these counters, they're all documented here. So this is guest OS, this is guest CPU run queue. We talk about the counters, we talk about what is a healthy value, and we profile the environments here, right? And then based on that, then I set the threshold. Now I would recommend that you profile your environment, but I'll be quite surprised if you get the different numbers. I'll be very keen to know your result. Right, and then and then we have CPU co-stop. Why CPU co-stop? Number 3, why not overlap? Well, because it is part of a CPU state. See, a VM is either running or not running, right? The CPU. And so you got the co-stop and ready here. So this thing is being discussed in depth, right? And how they are related, what is a good value, what is a bad value, right? And again, we profile them, and based on that, we establish the threshold. Right, and then you get the VM weight, VM overlap and system time, and then we match to context switch. E1, they're not color coded. It's a bug. No, it's not a bug, man. I'm just not sure what to put, because when I profile these counters, the result is so wide that I'm not sure what to put here. It's like I got 3,000, I've got 10, and I got 1 million. So what do you want me to put here? I'm not sure about it, right? So this is my profiling, right? And take a look at it, right? See what numbers you get, and then based on that, you color code it, because that's specific to your environment, right? I can't color code it on every customer's behalf. It's a bit, I might make a mistake, right? But you can, because it's your environment. And why CPU usage is last is because it has negative correlation, right? There's negative correlation, and right, it is also because if it is hardly utilized, it could be a performance problem. That's why it can't even run, right? And plus, if you just need 1+ CPU, configuring with 2 CPU will likely result in a better performance than configuring it with 20 CPU, right? Now you may say that, hey dude, why you round all your numbers without decimal? It's because they're not that significant, right? And anyway, your remediation action is going to be the same. Why these counters are not shown? I documented here the behavior why and when exactly you want to choose this thing. There is a use case for that, but by and large it's not required. It's gonna confuse most customers. That's why I don't have it. Now something that you may want to add, if you have the screen relay state, it's just not the CPU usage disparity, right? That is useful when you have monster VM with a lot of CPU, because you're not going to analyze it one by one. But what you want to do is there an imbalance inside there, right? So that is the CPU. I hope you see the logic. Okay, the same thing being applied on memory. And like, why is contention the only one color coded? Well, because none of this thing is actually directly measuring performance. Let's take a look at this. This VM is experiencing heavy ballooning, right? But you can tell the contention is, there's basically no contention. The only peak, so-called peak here, is not even 1%. So I'm not gonna worry too much about it, right? So that's why ballooning is not color coded, right? And like, why is that even placed towards the end? because when it comes to memory, you want to measure at Windows and Linux level. So these are all guess level, right? And we talk about it over here. That memory is, there are layers upon layers. There are actually 4 layers between the process, what a process see, and what your ESXi actually manage. There are 4 different layers, right? And so you want to get close as high as possible. So that is memory, right? And then moving on to storage, again, the most important one is the guest OS is disk queue. So we have the disk queue, while the most important one for the VM is a peak latency. This is a peak latency because it is the highest of the read and write of 20 seconds of any virtual disk, right? So it is, if I get here, maybe I'll show you an example. Take a look at this. This VM has 2 virtual disks, 1 and 2. Read. Each of them has read and write, and then 20 seconds. This happens to be the highest. That's the number that you are seeing. So that's why it's expected to be higher than the rest, right? And everything else, as you can expect, the IOPS and throughput are not color coded, right? And I round to the nearest numbers. By now you know why, because it doesn't really matter. 28.1 millisecond, 28.9 millisecond, it doesn't really matter. Now moving on, the last one to network. We don't have latency counters in network, but take a look at the drop package. It's I don't put the receive package, and I document it as I'm seeing a lot of significantly higher drops receive versus drops transmit. That's why I'm not using it. It's more than 10 times higher, as you can see it here. And that's basically it. This is the performance alert, which you can customize. I'm sure John Diaz, Matt and Brandon are going to explain to you the magic of vRops, yeah. And same thing at virtual disk here. They're going to explain all these things to you. I hope you enjoy it, and that's basically it.